You should be able to translate between things that are in the summation notation and writing them out in the expanded form. If we do this just one term at a time, it's not too tough. Here, the initialization starts at 1. So the first term is going to be 1 times 1 plus 1. The next term is going to be 2. So it'll be 2 times 2 plus 1. The third term is going to be 3 times 3 plus 1. And this will go on up until we get to n. So the last term is going to be n times n plus 1. Now, I don't know, is it possible to simplify this? Well, what it's looking like is it's 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5 up to n times n plus 1. Let's try another one that has factorial notation. Here we're starting at 1 and we're going to k plus 1. So when we start at 1, the first term is going to be 1 times 1 factorial. The next one is going to be 2 times 2 factorial. The next one would be 3 times 3 factorial, and so on. Now the very last term here would then be what? It'd be k plus 1 times k plus 1 factorial. Now, as a little hint, in between here, what would be the term before it? It would have to be 1 before k plus 1, which is k, and the one before this would be just k factorial. It helps to be able to figure out what is the term before something in doing some of our other problems. That may be helpful for doing problems where we have to separate off the final term. So here what we could do is we could expand this one in number 38, and when we expand this, we get, well, let's do it. It's going to be 1 squared plus 2 squared plus 3 squared up through the last one, m plus 1 squared. Now if you think about it, the term that's before that is going to be m squared. So we could rewrite this as being the sum from when k goes from 1 to m of the k squareds plus the last term. That kind of process will be very helpful in solving some of our future problems.